Hey Bruce, Bill here. Thanks for sending me the video. It was pretty informative. Just kind of an overview. I'm trying to get some structure in projects, and hopefully the onshape community will listen and we get some organized data out there. Let's see. I mean, with SolidWorks, right, they taught parts, assemblies, and drawings, but they never really talked about how to put an assembly together. And I think that's really hurt. And hopefully, with Onshape, we can change all of that. Don't know, maybe not. So anyway, that's kind of the reason why I'm talking with you, to see if we can't come up with some type of a way to handle a project. When do you use Part Studio? When do you use in context assemblies? So this is one project that I worked on. I think I've talked about this in some of the forum posts, but I was just going to go into a little bit more detail. One thing to note about this is I inherited this. Most of the projects that I deal with, I inherit because they're so messed up that they call on me to fix them. And it really is a tedious task. And it's one of the reasons why I'm so bitter as to why people don't know how to put projects together inside of SolidWorks. I think there's a way to do it, and I wish that people would explore different avenues. In the world of Pro Engineer, there was ways to put projects together, ways to put assemblies together. In the SolidWorks world, it's kind of left up to the individual to figure it out, which I think isn't a good practice. So I'm trying to come up with some ground rules and hopefully share the knowledge with people. I wanted to bounce my ideas off of you, look at how you're doing it. You and I do things very similar. And hopefully maybe we can come up with a good set of easy to understand ground rules to get things done. So with this one, I'm just going to go over some of the basic stuff. Whenever I start a project, I'm not talking about starting an assembly, starting a part, starting a drawing. Here's a project, okay? And in your case, I guess, look, I need a piece of equipment that does this. And in this particular case that I'm working on, this is a piece of automated equipment that fits on top of a desktop. And it could also go in an automated cell. But this project, its top level, is basically just the machine itself, and it's going to sit on a desktop. So this is the top level for this particular assembly. It's not easy trying to figure out what the top level is going to be. I mean, a lot of times top levels, if you have options, has to include multiple top level assemblies. In this particular case, this rolls up into one top level assembly. Okay. This was such a mess. This had 3 engineers working on it. They did bottom up, so they designed each part, they threw it into an assembly. It kind of looked right. They ran off, they built all the parts, they brought it in, nothing bolted together. And that's when I got the phone call, hey, what are we doing wrong, right? We did it by the manual. All these kids graduated school too, with SolidWorks experience. And it didn't quite work out. So the first thing that I ended up doing is I added structure to what it was that they were working on. And the other thing that I don't want to do is work with tons of files. So if you look at this structure, everything's virtual. So here's a subassembly, here's a subassembly. So this is basically the folder that all of this stuff is stored in. So I'm running everything virtual. Used to run everything in multi-body parts. Found that virtual assemblies work better. Of course, they fall apart when you try to start doing drawings. So yeah, the SolidWorks world isn't perfect by any means. The other thing that I wanted to do in this particular case, let me turn this housing off. My first job was to figure out the sub-assemblies. And since I had 3 engineers at my exposure, I wanted to be able to get 3 people working on this simultaneously. So the first thing that I ended up doing was breaking the project down. This is the structure, this is the grip assembly, these are the spinner cones, and this is the tray that moves this thing around. There is some motion inside of this, so this goes up and down based on the bottle jack. This particular assembly will extend. Okay, and then of course the tray and all of this good stuff. Okay. The way that I structured this isn't real sophisticated. It basically uses these three datums. So the top level datums, these datums go down into each one of these sub-assemblies. So if I look at how this sub-assembly was put together, it basically calls up the root sub-assemblies, and all of these assemblies are assembled off of these roots. Okay. Also the parts inside of this part is actually, look, if we take a look at these planes, they actually map up to the top level planes. Okay, up to here. They could go to here. Okay, I really don't care. Since these are assembled by coordinates, then these can be assembled by coordinates. But all of this stuff gets mapped out, the orientation, and everything is put together based on these top level assembly coordinate systems so that the thing would behave. So if I take a look at the structure, I have a top level, I have one sub-assembly, and the reason why I broke this up into sub-assemblies is so that I could have multiple engineers working on this project. One of the things that I didn't allow is that the grip sub-assembly couldn't talk to the main structure, so that these guys could not reference and create in-context references between these top-level assemblies. First off, it was a mess, and assigning when they could and could not use assembly references was key. Once you got into this sub-assembly, then they had sub-assemblies. I really didn't care how they did it after they got into their own little sub-assembly. And then they could have all the in-context referencing that they wanted. They could use multi-body parts. That much I didn't really care. As the project manager on this, I cared about the top, and then I cared about the referencing scheme in between the top level sub-assemblies. And turns out we ended up making this thing, it all bolted together. One other thing, let's go over. Whenever I handed off a sub-assembly to somebody, I never said, oh, I need an enclosure, it needs to be this big. Okay, one of the things that I would do in a case like that is I would always hand somebody a seed file, and in this case, I handed the engineer this sub-assembly with this part in it, which was a reference, and this part literally defined how big this case should be. So when this person actually started working on this enclosure, they didn't start from a blank slate. Okay, they started from the assembly that I gave them, and my assembly had references inside of it. This really helped out because when I got the assembly back, boom, it just goes right into the assembly. And that's one of the key ingredients to assembling based on coordinates, right? As opposed to trying to mate up against faces, because you'll lose those references. So we had different schemes to actually hand off projects to people, or hand off a seed file to get something started, knowing that when it came back, it was oriented in the proper fashion. And also the references, we knew how the reference would actually talk to the top, and we controlled the referencing scheme on how to put all of this stuff together. Let me go through my notes. Oh, there is no layout in this particular design, and it really was a disaster. We never really knew what the stack up was, and sometimes we'd have to add a spacer on here. You know, if I got to do this over, I would definitely have a sketch out, a layout like you did. I'm more interested in defining datums as to, okay, this sub-assembly, here's your datum, and work with that. That way at a top level, I can move the datum, and hopefully the sub-assembly updates and knows how to behave. So to me, it's all about datum. There's no layout in this. That's a problem, and we've lived with this problem for quite some time. Let's see, what other kind of notes do I have? There's no references between the sub-assemblies. There's no bodies or no multi-body parts in this. Okay, so don't really know why we're going to be doing multi-body parts. I know in onshape we've got to use them. We got to know when to use a multi-body part, when we're going to do in context. I've got some ideas. But listen, in SolidWorks, they've had multi-body parts for 10, 15 years, but nobody knows why they should have multi-body parts inside. For weldment, cutlass, I mean, come on. What's that all about? So I guess that's just an overview as to one way to put together an assembly. I have some other examples I'll put together. Just trying to formalize a methodology and a global way to think of, okay, here's a project. How am I going to put this project together? How am I going to put these assemblies together? How many engineers do I have working for me? And how am I going to control the referencing schemes? How am I going to get it to articulate? How am I going to control my datums? These are kind of the things I'm trying to work out in my mind. And who cares about SolidWorks? Right now, I'm just trying to define all this stuff inside of onshape. I guess that's like everybody else. Nice working with you. Good to meet you. When you're in Southern California, definitely stop by. I'll buy the whole family lunch, okay? I'll talk to you later.